test? Friday the whatever that is. Maybe a couple points. So, all right. Shh. Okay. Ultimately, we want to know the resultant vector. Okay. So, when we talk about this, let's talk about a very high level. How do we think we're going to deal with this? Sam, are you taking notes on that?
Yeah.
Okay. How are we going to do this? Someone talk me through generally in high level how we're going to do this. How do we think we might attack this? Anybody? Number one. Okay, you guys speak up. Michael, go ahead, speak up.
Draw the resultant vector first to see what you're trying to get.
Okay, let's see if we can draw the resultant vector first. So we'll draw it in red, okay? The resultant vector goes from where to where? From the start of my first vector to the end of my last vector, right? So there's my resultant vector. I'm going to call it R. R vector, okay? Call it pink elephant. Call it, U. I don't care. R. I'm just going to call it R for resultant vector, okay? And honestly, I might call it because we're using distance in this case. I'm going to call it D for displacement vector, okay? Because I got two displacement vectors. And what am I doing? Let me just come back to this one thing. We talked about it briefly before, but we're taking this one vector here, right? Shh, guys, pay attention over here. And we're taking another vector here. And what are we doing with these two vectors? What are we doing with these two vectors? Open the door for him. Yeah, but what are we ending up doing? You're late.
I passed out papers and I told you I was going to the bathroom.
When I called for attendance, you were not here.
You can't go to the bathroom.
I did say that. That's true. All right. Okay. So I've got my first vector. I've got my first vector, which is 5.4, and I have at a certain angle of 30 degrees. And I have a 7.8 vector, 7.8 meter vector at 20 degrees from the horizontal. What am I doing? What am I doing to get this final vector?
Combining the two.
I'm combining the two. I'm adding the vectors. I'm adding the vectors, okay? So if I were, let's look at a basic concept, okay? Shh, David, let's pay attention, please. Okay, if I have a vector here, and I have a vector here, right? And I add them together, what do I get? Right? Excuse me, I got blow my nose. So what I'm actually doing is I'm taking this vector, and I'm moving it where the beginning of the second vector starts at the end of the first vector, aren't I? Everyone see that? Is it this? Everyone, is it this? No. It's this, okay? Now look, the end result is a vector that looks like this. Oops. That looks like this. What is so funny, guys?
There's just like music for it. Grab the music, turn it on for like 5 seconds.
Okay, let's focus here. This is important. This is really important. Shh. Okay? In order to get from point A to point B, I had to go a certain amount in the what direction?
X.
And then a certain amount in the what? Y direction. So if I add my components, these are components. Everyone say it with me. Components. This is the what component? The X component. What is this one here? The Y component. Okay? Now look. Here's the thing. If, however, I took and I said, well, the first vector was actually this way. What if I added this vector to that horizontal vector? Do I add it here? What's the difference between this vector and the other y vector? What's the difference? This is doing what? Pointing down. So when I add this new horizontal vector, the negative one, to my, vertical vector. When I add this new vertical vector, which is negative, to my original horizontal vector, notice my resultant is completely different, isn't it? My resultant is a different vector altogether. Do you guys see that? So what we're doing is we're adding vectors. Now you guys watched my video, right? You watch my video, right? Okay. So I'm getting a different y component. Now both of these resultants, resultant 1 and resultant 2, have the same x component. They just have what?
Different
Y components. Is that clear? So I'm adding them together. I'm sensing Siva. Please sit down. Take part of the class here. Okay. Netta, thank you for paying attention. Or she's at like zombie zone, like staring at me. It's good. No, I said, Netta. I said, thank you. I just said thank you for paying attention. You're like weren't even blinking. You're like staring at me. All right, shh. Guys, does everyone get this? Shh. Okay, does everyone get this? Does everyone understand this part? Everyone with me? Yusuf, you good? You can say no if this is an issue. Let me know because this is important. The rest of the majority of mechanics for this semester is going to base itself on this. So if you don't get it, yell it out. Good? Good? Okay. Shh. All right, so I'm going to delete this. Shh. So, actually, hold on before. So in order to get this R1, what did I took the x component and the y component and add them together, right?
Yes.
To get R, right? But I could also do what? I could take the R component and do what with it? I can break it down to these other two components and go the other direction, couldn't I? Okay, so if I think about, this is what I did in my in my talk, right? Was if I have one vector here, I've got one vector here, right? And I have another vector here, say, right? Okay, I have a x component that goes from here to here, don't I? Right? I have another x component that goes from here to here, don't I? Correct?
Yeah.
The total x component from where I'm, let's say I'm going to end here and start here, right? Oops. The total x component is this, isn't it? Right? Everyone see that? The x final is equal to, and see I have x1 and x2. What's x final equal to? Does everyone see that? So all I'm doing is I'm breaking them down into my x components. Now look at the y component part, right? If I do the y component, okay, I've got the y vector and then the y vector, sorry for the pea green looking color, right? I have a complete y vector coming up to here. Oops. Excuse me, right? And that y vector, the y final is equal to what? What's y final equal to, guys? Right, y1 plus y2, right? Equals y1 plus y2. Does that make sense, guys? So what we're doing is we're taking these vectors and we're breaking them down and adding them up. Is everyone clear? Okay. So this is the basic construct for all of this stuff. Now, the last problem, which you guys were like, oh, no, I do. It's exactly the same way. What?
I understand it now.
You understand it now, right?
Makes me angry.
I know, right? That was my goal, was to make you angry, right? Okay. Do you guys want me to do this together, or do you want to try it again on your own?
Do what? Try to get on our own.
Okay. Do you guys?
Definitely not that.
Do you guys listen up? Listen up. Do you guys want to try this again on your own, or do you want me to do it with you together?
Together.
How about I give you? How many? Wait. How many of you guys finished problem 1? Raise your hand. How many of you guys finished problem 2? How many of you guys finished problem 3? Okay. Do you guys want to work on problem 3 on your own?
We're almost on problem 3.
What now?
We're almost on problem 3.
Okay. So why don't I? Okay, hold on. Does everyone? Do you feel like you have a newfound understanding of how to do this?
Nope.
Okay. Let me finish. Let me finish number 1. Let's finish number 1. Okay, that's okay. That's all right. Shh. It's okay. All right. Let's do it together. Let's do it together. All right. Here we go. Quiet. We're gonna do number 1. Shh. All right, so we're going to do number 1. So now here's the thing, right? So notice, if I take this, let me come back here and hold on, layer here. I'm going to blow this up and bring this over here, okay? Oops. Here's my displacement vector D, okay? So I'm going to call this 5.4 meter thing. What am I going to call that vector?
Vector 1.
Okay, I'm going to call it D1. Okay? What am I going to call the other vector, 7.8? Beautiful, D2. Okay? All right. How do I get the final resultant vector for D? Let's call it D final for the heck of it, right? D final. How do I get the final? In order to get the final vector, what do I need? I need what of it? What do I need?
The angle of it.
Well, ultimately, I'm going to get what do I need to find to get the to get the angle? Right now, what do I know about DF? What do I know about DF?
It's the hypotenuse. It's the combination of D1 and D2.
It's a combination of D1 and D2. Do I have the length? A vector is made up of what two things?
Length and magnitude.
No. Guys, it's not. Okay, everyone stop. Everyone, let's be very clear about this. What is a vector made up of, David Dentino?
I just got it wrong somehow.
Say it again. A what? A what and a what?
Length and
A length is the magnitude.
direction.
David, you need to know this.
Now that 3 other people got it wrong, yeah.
Right. All 3 of you need to know it. David Dentino, listen to me.
Now you're pulling me out.
Now I'm picking you out, okay? Guys, you need to know the magnitude and a direction. A vector is a magnitude and a direction. So you need to know do you know either the magnitude or the direction? Guys, do you know the magnitude or the direction for the resultant vector right now? No. What is this? How do I figure out the magnitude and how can I figure out the magnitude? Let's just start there. How would I figure out the magnitude of this? If I knew, what would I need to know to do it? What could I need to know? The height. I could know this length right there, couldn't I? If I knew this, that would give me a start, wouldn't it? But can I figure it out only if I had the height? I also need the what? The x. So notice I need the dfy. I also need the what? The other 2 legs of the triangle, that's dfx. X direction. The x direction. Do you guys see that? And if I knew that, what would be my d vector? What would be the magnitude of my d vector if I knew those 2? David Dentino. Come on, buddy. Okay. How would I know df? If I knew those 2 values, how would I know df, guys? Come on. This is Pythagorean theorem, right? The magnitude of df squared equals what? dfx squared plus dfy squared. Guys, there's too much talking. Too much talking. Does everyone understand this? You all see this. Let me know. Yell. Yeah. Do you understand it? Yes or no?
Yes.
Does anyone not understand it? Okay. All right. Once I have these 2 lengths, I can figure out the hypotenuse, right? What else could I now figure out, Dentino? The angle. I can figure out this angle here, which would be my theta, right? And David, how would you figure that out?
How would I figure it out?
The what?
Wait, what?
If I knew this length, I knew this length, how would I figure out the angle?
SOHCAHTOA.
Okay, but which part is SOHCAHTOA? If I knew this length, the horizontal and vertical.
Okay. You have DF. You're looking for which one?
Well, we're looking for the angle, so if I have this value and this value, what would I use?
You underlined one.
I underlined this one. I'd get this one and this one.
Okay.
Let's say I have the value for both the dfx and dfy, David.
You could do.
Which one would I use to get the angle?
That would be the sine inverse.
What I'm asking David Dentino, what would I use?
Know how to do SogaToa. Yeah.
Leave him
Put me on
alone.
the spot like this like every 5 seconds. Wow.
David Dentino. If I've got the horizontal and the vertical here, kiddo, what would I use? What trigonometric function would I use to get the angle? What?
Sine. Cosine. Tangent.
Which trigonometric function uses the angle, opposite, and adjacent?
Tangent.
Okay, which one's the opposite? Up here.
DFY.
Beautiful. Which one's adjacent?
DFX.
Okay, good. Thank you. All right. That's how we're going to figure that out. But I need those two pieces. So someone else tell me, how do I figure out DFX? Let's start there. How do I figure out DFX? What does DFX equal? Not DFX, but D1X. Right? D1X plus D1Y. You guys see that? Yes, ma'am. Shh.
Do you have to denote it like that? Because I definitely don't.
No. I'm just, look, you don't have to denote it like that. I'm just showing you, I'm denoting it this way so I'm clear to you guys, right? You're going to have to denote it in some fashion.
Like,
You got,
it doesn't have to be like that.
Well,
Like, with like D, like,
you can use R, you
as
can
long
use
as
S,
it's clear.
but you need to use variables. You need to denote it in this fashion. You need to denote it with variables. Now, you can say, well, this is D and that's D, and I will probably on a test, so I don't go crazy, I'll call it something. And you'll have to use what I call it. But you need to know that it's D1X plus D1Y. You get if I know that D1, D2, then you need to denote it like this. Does that make sense? Okay. Yes, sir. Oh, excuse me. I'm sorry. Thank you. Thank you for catching that. Oops. For y'all listening, my mistake. 2x. Thank you. Right? It's D1x plus D2x. Right? And so dfy is equal to what? What's dfy? Does everyone see this? Because I don't hear any response. Okay, so d1y plus d2y. Thank you for Mr. Mays for paying attention and catching that. All right, does that make sense? So how do I figure out each of these values, guys? How do I figure out these values? How do I figure out d? Let's start with d1. How do I figure?
Do you use sine and find D1?
Okay, so let's draw the triangle. Let's draw the D1 triangle, okay? Here's this guy, okay, and I have this here and this here, right? Right there, right? Here's D1, right? Right, here's D1. Okay, and the angle is 30 degrees, right? And that value is equal, the magnitude of D1 is equal to what? Zach, what's the magnitude equal to?
I'm not sure.
Why not? Because you're not paying attention. You're looking on Civa's computer. Focus up here. What's the magnitude of D1? What's the magnitude of D1? Look up here.
It's just
The magnitude of D1. This is my D1 vector right here. Here's my D1 vector. I'm redrawing it. What's the magnitude of D1?
So it just be D1 and D2.
Just D1.
Just the magnitude of D1. Someone help him out. Yusuf.
5.4.
5.4. 5.4 what? What? Meters. Okay. Okay, I'm going to do this. Okay, Zach, you're sitting over here. Siva, you're sitting over there. I'm splitting it up. Netta, you come over, sit where Siva is sitting. It's not your fault, Netta. You're good. Actually, then you can sit there. But Zach and Siva, you guys come over to this table here. Okay. Siva now. Siva, go sit down. Done. Okay, you guys, this is killing this table. Trip, are you with me? Okay. Okay, you can sit. No, I just said sit right there. Thank you. This is so important, guys. This is so important that I don't want you guys to screw this up. That's why I'm doing this. All right? This is really important. The rest of the semester relies on this. Or at least the rest of mechanics relies on this. Okay? So I've got D1. How do I figure out D1 x and d1y. How do I figure that out? How do I figure it out? D1x is the length I've called for D1, right? I'm taking D1, which is my 5.4, I'm redrawing that triangle right there.
All these letters are kind of confusing. Because you already used D1x on the...
Because it's the exact same thing. It's the exact same thing.
Yeah,
This
but-
triangle is right here.
Oh.
D1y. I'm just redrawing.
Okay,
Because while you were talking, I was explaining that I'm redrawing this triangle down here.
Yeah, but like you use df of x on the one above.
Because df of x is the final, the whole full length. And I said df of x is equal to d1x plus d1b plus d2x. You follow this? So there's a okay. Okay, let me.
Why don't you just draw a separate triangle?
I'm gonna do this. How about this? Ready? I'm gonna draw this. All right, let's do this. I'm gonna draw a triangle here. I'm gonna watch. Here's this D right here, right? Okay. Window, brush puck, bigger. Here's a D right there. Okay. You guys see that? Okay. There's one D, right? The next D. Okay. From here to here. The next X. Okay. Okay. And then there is a big final right here. Oops. Right here, right? Okay, is this making some more sense? Where this is dfx, right? And this is d2x, and this is d1x. Does that make sense? Do you see how I'm doing this? Where this is D1 of this triangle, and this is D2 of this triangle. Do you follow that or no?
Yes.
You can say no.
Yes.
Here's my D, like this. There's my D2x. You guys see that? All I'm doing is I'm dropping it down. Do you follow that? Okay, so now is that clear? Okay. So I've got D1x and D2x. I add them together, and that equals my dfx. So D1x plus my D2x. Is that clear? You with me? Okay, everyone got me? So now what I'm doing is I'm drawing that first triangle. I'm looking at D1. And I'm just trying to figure out what the D1x is and the D1y is. So how do I figure out D1x? What do I got to do?
Is D1x the
D1x is
is that the one right here? The small one? I really can't see that.
Okay, then you guys come up.
I get it. Yeah.
So if this is my 5.4.
Yeah.
My
it's
x
that one right there.
It's
right?
yes, it's this guy right here. It's 5.4, right?
Okay, got you.
Yeah, so I did this, right?
Oh.
So I'm drawing this triangle here.
Yeah.
Okay.
I didn't see that.
Okay.
So wouldn't it be cosine 30?
So let's start from the top. What am I? If I'm looking for D1x and I have an angle of 30 degrees, what thing do I have? What do I have? I have the 5.4, which is my what? My hypotenuse. What am I looking for?
Your leg.
Which is the what?
Cosine 30 over
No. Wait. It's the adjacent to the angle. I want to start there for a second. Let's do this. I'm going to do this real structured, and I'll tell you the shortcut in a second. Okay? All right, here's the thing. I have the cosine of my angle equals what? Adjacent
over
hypotenuse. Guys, when you're doing this on a test, shh. Well, that too. But I want you to start here. Why do I want you to start here?
You can see our thought.
Yes, I can see that you're doing this because if you do it wrong, I can give you some partial credits. Okay. For now, for the first piece, I want you to do this so I can understand this. I can understand where you're at. We'll do the shortcuts as we move along. Down we get into forces, things like that. But for right now, I want you to do this. So cosine theta equals my adjacent of my hypotenuse. So the cosine of what's my theta angle? 30 degrees. What's my adjacent? D1x over my hypotenuse, which is what? 5.4 meters.
Oh.
Okay? So now, so D1x equals what?
Cosine 30 times 5.4 meters.
Yes, 5.4 meters times the cosine of 30 degrees. Now look, here's the deal. What is this cosine 30 really doing for us? What is it really becoming for us? Beautiful. Beautiful. Nicely done. It's a percentage of 5.4. Okay? Okay. Okay. Shh. Quiet, quiet, quiet. Okay, now so that D1x is equal to what value? Someone tell me.
4.67654.
How much?
4.67 meters.
4.67 meters. Thank you for putting in the units. So there's my D1x. What's my D1y, guys? What's my D1y? How do I figure out D1y? How do I figure it out? No. Use it with the sign. I want to use trigonometry. Okay, sine of theta equals, start there. Sine of, guys, sine of theta equals what? Opposite over hypotenuse. So the sine of 30 degrees equals my opposite, which is what? Now, Chris.
D1y.
D1y over what? What's my hypotenuse? Okay, so therefore my D1y equals what? 5.4, I did that again. 5.4 meters times the sine of 30 degrees. So D1y equals what?
2.7 meters, right.
Okay. Now here's the thing. I want you to be very clear about this. Here's the deal. I'm going to give you a shortcut, but you have to be very careful. With power comes great responsibility. Yes, ma'am.
What is the percentage of?
It's a percentage of this. The trigonometric function is essentially a percentage.
Of what?
Well, okay. Look here. Of whatever it's multiplied against. So if I look at 30 and I say cosine, it's 0.866. So it's about 87% of 5.4. You see what I'm saying? Does that make sense? Because it can never be greater than 1. The cosine or sine of an angle can never be greater than 1 or negative 1. Right? Does that make sense? So it goes from 0 and then it's never less than 0. It goes negative 1 to 0 to 1. It can be any of those in there. Does that make sense? All right. So here's a shortcut. But again, with great power comes great responsibility. Be careful that if you're going to do this, be careful that you are not messing yourself up. Because when we start to do some other things down the road, the orientation may mess you up. But here's the gig. Notice for the x, for D1x, it is the hypotenuse times cosine of the angle in this scenario. So let me do this. So if I have a triangle, okay, and here's my hypotenuse. Here's my theta. In this case only, when it's set up with the right triangle to the right, okay, where this is my hy component and my hx component, okay? Hx always equals, when it's set up this way only, okay, h cosine theta. Hy is always h sine theta. Okay. Remember, if you go back to your unit circle, let's look at y. Oops. Right? If we think about this, if I've got my hypotenuse here, right? Boom, 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 right? If I have x comma y, right? If this is cosine comma sine, right? Does that make sense? Okay. So the if I'm looking for my x component and I have it set up in this orientation, my x component is always the hypotenuse times the cosine. Okay. The reason we care about this, guys, is this. Okay. Okay, stand up for a second. Hold still. All right, here. Hold your hands. Come over here. Come over here. Come over here. Hold your hands out like this. Hold your hands out like this. Okay. Yep. I'm pushing on you in which direction? Straight at you, right?
Yes.
Okay.
Goes into the
Okay. Push your arm and hold steady. Okay. Now, if I push at you with the same force up, can I keep it down? Keep it right. Okay. What's happening? Am I pushing at? What am I doing? I'm pushing at a what? At an angle. Okay. But there's a portion that the amount that's pushing into your arm is the same. Does it feel the same as before? Feels what? It's less. It's a percentage less.
Ooh.
Am I pushing the same amount? Yes. But now it's pushing up. But now you feel some portion up. Does that make sense? Now it's all up and nothing horizontal. Right? Does that make sense? So what I'm doing is I'm splitting up the force into x and y component. Thank you very much. Does that make sense? And so when we start to do things, we're going to be able to deal with that force in that way. Does that make sense? Clear? Okay. Okay. All right. So I've got my d1y and my d1x, right? What do I got to do next? What do I got to do next?
D2y.
I got to do d2y and the d2x, right?
Make the other little triangle.
Okay. So I'm gonna go ahead. Can I erase this down?
Yes.
You two, put that up here in the front, please, and stop messing with stuff. Zach, did you have this completely done
I did.
and correct?
Yes. Well, I did.
You've all the work shown?
Yes.
Really? I don't see much work on there.
I didn't write like the main equation.
Okay, I want you need to be taking notes. I don't see a pen in your hand. You need to take notes. Make sure you're following this methodology. This is what I want to see in the test. Guys, this methodology of D1, D1y, D1x, x and y, you gotta show me this. Don't just give me an answer. You gotta show me the work.
If we just call it like x and y.
What if I got two x's? You gotta tell me which.
That was an example. Like, what if everything has a different letter?
Yeah, then you're gonna have to say y, pink elephant x and y, purple
Right.
dinosaur x and y.
Like, you can't just be like, oh my god, okay. I was just going with your example right there.
Yeah.
You could just be like, normal pink elephant, not x and y, just because it might get confusing with a lot of x and y. It could just be like one, then like.
Hold, wait. No, David, continue talking. I don't understand what you're asking.
Okay. Could it, instead of being like dfx and like d1x and d1y, could it just be like, I don't know, like something completely different just for that one thing? A, B, C, D.
Because
Yeah, like just like a set of letters.
Yeah. That'd be a lot.
No.
the reason I want you to put the sub x and y, so we all know what you're talking about. If you just call d1x r, then I would, as I'm going through your sequence, I would not understand what r is.
But if we label it like on the, if that's the first thing we labeled it, you still would.
I want it sub x sub y, and there.
You want it specifically, okay.
So whatever it is, now let
R sub x.
yes, that's fine. If you label David, if you label this vector r,
Yeah, and then R.
and it's r sub x, r sub y.
So
Okay,
you have to do sub x. Sub
yes, because otherwise you don't know what you're adding, and I don't know what you're adding,
Okay.
and it's going to cause you less confusion. Trust me. Okay. All right. Can I erase this part? Hello. Can I erase this, please?
Yes.
Thank you. Oh, hold on. Try that again. Psych. Okay. Shh. Okay. Now, I'm going to erase this up here. So let's do the other triangle, right? Let's do the other triangle. So I'm trying to say, okay, I've got a triangle here, right, which is this guy, and that guy, right? What is this? What are we calling this vector up here, guys? What are we calling this vector here, guys?
It looks like D2.
D2. Right?
Oh, you're talking about D2.
Okay. So what is this component of D2?
D2.
D2x. And what is this guy up here?
D2y.
Beautiful. Now we're cooking. Okay, what is the angle here, guys?
It's
wait.
70. Oh wait, oh no.
20 degrees.
Wait, what?
Yeah. It's
Oh yeah. I would. Okay.
Okay.
I thought it looks like the other one, but then on the paper I knew which one it was.
Okay, so it's 20 degrees. Okay, we good?
Yes.
Okay. So the value of D2, the magnitude of D2,
Okay.
Magnitude is
7.8.
beautiful.
meters.
Now, beautiful. 7.8 meters. That's the magnitude. Okay. So what is the magnitude of D2x? Let's do the shortcut.
Oh, you know what?
I'd like you to show me the D.
It is the
D2x, because it's the x component,
7.8.
is D2 times the cosine of theta.
Yeah.
You may, by the way, you may use this as your equation. You may use that as your equation if it's set up in this way. You don't have to go through code because you guys are honors. You have to go through the whole SOHCAHTOA thing. But you do need to start somewhere. And if you're gonna do the shortcut, you've got to start here. Does that make sense? Ned, are you good?
I didn't see it as a shortcut though.
Well, versus having to go back and forth and saying, okay, the cosine of theta equals adjacent over hypotenuse. You know, you're giving a couple of steps off, okay? But I still want to see you're doing this. Shh. Guys, I know you guys fight tooth and nail about showing work. The problem is okay.
I don't
all
try to
right.
do it. I feel like I always try to show work, and then you always come back and you're like,
You gotta show
I lose
work.
so many points.
I know. So do it. So
I'm
learn.
trying to show you work, though.
Show me. Look, if you show it this way, look. It's not a guessing game. I'm showing you exactly what to do.
Well, like, I'm not trying to make it hard.
Don't say like, oh, that's really great, but I'm gonna do it differently. Well, I mean, you can do it. You can solve it different ways, but you show me the work this way, and you'll be clear. All right. Shh. So D2x is equal to what's my D2? Hello, everybody. 7.8 meters times.
Cosine
20.
Great. So D2x equals what?
7 point.
No.
Wait, you just did D2x.
2.667.
Oh, you wrote D2y, but you said
2.67 meters.
2.67 meters. Right? Notice how much easier this is now, right? Now that you've not had to go through this multiple step. Siva, what are you doing? What is that piece of paper in your to the right of you? Okay, are you typing for English?
No, this is physics.
Okay, it looks like you're looking at the paper and going to.
I was reading the physics thing, or English thing that we're supposed to be reading, and I was typing the
Okay,
physics.
okay. Do not do other people's homework in my class. Is that clear?
Yes.
Guys, I see this. I'm going to have so little sympathy for you on a test. Okay, and I didn't see you make 100 in the last test or quiz, right? Am I wrong on that? Okay, your goal should be, if you guys pay attention, you could easily make 100. That should be your goal. That means you got to focus. Okay, so now how do I figure out, what's the next thing I got to figure out, guys?
D2y.
D2x.
D2y. We just did D2x. So what's D2y equal to? D2y is what?
7.8 cos.
No, give me the equation. It's the,
D2 cos theta.
D2 times, David,
Oh, sine, right. I was just looking at the other one.
sine theta. Does that make sense?
Yeah.
Now look, if theta is up here in the top right corner, doesn't work anymore. It's flipped. Does that make
Yeah.
sense?
Wait, I think this.
So if this look if it's, let's say we're using phi. If I'm looking for the angle phi, D2 sine phi is this leg here. I'm just calling another angle.
What did you say?
Phi.
I thought you said feet, but then I thought
Phi. Phi. What? Oh, what?
Okay, I feel isn't D2x? D2y is 2.6.
I don't know. I asked what the answer was. Someone told me the answer. I didn't do the calculation. What is the answer for D2x?
D2x is 7.38.
Okay, so someone spit out the wrong number. 7.3 meters. Let's do it right here. Shh. I think Trip, I thought it was actually you, kiddo.
No, yeah, it was.
7.8 times 20 cosine. Trip, yeah, I can swear that came out of your mouth.
No, it was true.
It was Trip. Okay.
You're wrong.
Okay, relax. Okay. All right, we'll finish this up. Oh my